Hey guys, in this one we're taking a look at differentiating polynomial functions, and sometimes we'll also be finding the gradient at specific points. So, in the previous video we differentiated single terms of the form y equals x to the power n, so if you're alright with that, you'll be alright with this. When you have polynomial functions and you want to differentiate them, you just differentiate each term separately. So, let's get cracking. Okay, so for the first example, we have y equals x cubed minus x squared plus x plus 7, and we want to find dy by dx. So, we're going to get y dash of x, which remember is dy by dx, just alternate lazy notation. So y dash of x is going to equal, well, to differentiate x cubed, the 3 comes down, and then the power goes down by 1, so we get 3x squared minus, for x squared, the 2 comes down, and the power goes down to 1, so we're just going to get minus 2x, and then to differentiate x, if you're differentiating x terms, the x disappears and you're just left with the coefficient. So x has a coefficient of 1, so we can get plus 1. And then for the 7 at the end, when you differentiate constant terms, they just go to 0, they disappear completely. So that right there is our gradient function, our derivative. Good times. Now for part B, we're going to calculate the gradient of the curve at the point where x is equal to 1. So we just substitute x equals 1 into our derivative. So we're going to get 3 times 1 squared minus 2 times 1 plus 1. So that's going to give us, well, 3 times 1 squared is 3, minus 2 times 1 that gives us 3 minus 2, so that gives us 1, plus 1 at the end gives us 2. Okay, example 2, so we've got f of x is 3x to the power 4 minus 5x squared plus 10. We want to find the gradient when x equals 2. So, to be able to find the gradient, we need the gradient function, so we need to differentiate. Now, given that our function here is called f of x, we should either use df by dx or f dash of x. So, f dash of x is going to be, well, the 4 comes down and multiplies to 3. So that gives us 12x cubed. Then we got minus, the 2 comes down and multiplies to 5. So we can get minus 10x. And the constant at the end disappears completely. So that's our gradient function. Now we want the gradient when x is equal to 2, so we calculate f dashed of 2. So we're going to get 12 lots of 2 cubed minus 10 lots of 2. So 2 cubed is 8, so we've got 12 times 8 minus 10 times 2 on a good day is 20. So 12 times 8 is 96. So we've got 96 minus 20, our gradient is 76. Example 3, so this time we have y equals x times x plus 1 times x plus 2, and we want to find y dash of x. So, sometimes you're not always given a straightforward function, sometimes you will have to simplify it, or as here, expand brackets and then simplify. So, in year 2, we will learn a way to do this without expanding the brackets, called the product rule, but until then we're going to need to expand the brackets. So let's do that. So if we multiply the two brackets first of all, we get y is x times x squared plus 3x plus 2. So then if we multiply everything there by the x, we get y is x cubed plus 3x squared plus 2x. So now we have y in a nice expanded and simplified form, with no brackets or any funny business kicking around. So now we can differentiate. So x cubed differentiates to 3x squared. 3x squared differentiates to, well, the 2 comes down and multiplies the 3. So we get 6x, and that's it. The 2 gets reduced by 1. And then, 2x at the end differentiates to 2. So there's our gradient function, good times. Okay, let's get some fractional powers involved. So here y is root x times x minus 1. So we want to find y dash of x, the derivative. So, first of all, turn root x into power form. So the square root of x is x to the 1 half. So we've got x to the half times x minus 1. Now, we need to expand this. So, we've got y equals x to the 1 half times x minus x to the half. Let's write it as minus 1 times x to the half. So, remember that x as a power is x to the power 1. So, when we've got x to the 1 half times x to the 1, that's going to become x to the power 3 halves. And then minus 1 times x to the half, we can just write as minus x to the half. So there's our function, expanded and simplified. Now we want to differentiate it. So, go very carefully when we have fractional powers. So, x to the 3 halves, well, what's going to happen here? The power of 3 halves comes down in front. So we've got 3 halves times x to the, 3 halves gets reduced by 1 whole. 1 whole is 2 halves. So 3 halves minus 2 halves gives us 1 half. Then we have minus 1 half x to the, well, 1 half minus 1 is minus 1/2. Okay, so there is our derivative. Let's clean it up a bit. So, we've got 3/2 times x to the half. So, we can write that as 3 root x over 2. Remember, x to the power of 1/2 is the square root of x. So we've got 3/2 times root x, which we can write as 3 root x over 2. And then this chap at the end, well, we've got minus 1/2 times x to the minus 1/2 means 1 over root x. So we can sort that out a bit more. So y dashed of x is 3 root x over 2 minus 1 over 2 root x. Good times. Okay, last example for this video. So this time we're going to have negative powers involved. So this time y is 1 over x cubed times x to the power 5 minus x. So what we're going to have to do first, you guessed it, expand the brackets. So we get y equals x to the power 5 divided by x to the power 3 minus x over x cubed. So if we simplify that, y is x to the power 5 divided by x to the power 3 is x squared. And then the second term, x divided by x cubed, is going to give us 1 over x squared. Now, to be able to differentiate that, we're going to want it in power form, not as a fraction. So we've got y is x squared minus x to the minus 2. Okay. Now we can differentiate. So y dashed of x is going to be, well, x squared differentiates to 2x. And then for this second term, we're going to get minus 2 lots of x to the minus 3. So we've got 2x minus 2 gives us plus 2. And now x to the minus 3 we write as the bottom of a fraction, x cubed. So our derivative is 2x plus 2 over x cubed. Okay guys, that's it for this video. Hope it's helped. Next up, normals and tangents. So we're going to be seeing and practicing differentiation a lot. So if it's still a little bit tricky, we'll be learning it as we go. Take care guys.